For 5,000 years humans built cities with sweat and stone. That ends today. The next generation of cities will be printed. Imagine a city without workers. Not a ghost town, not silent and abandoned, but a place humming with ceaseless automated activity. A metropolis where structures are printed, modules are placed, security is patrolled, and supplies are provisioned, all by machine. This is the vision taking shape for our near future. A city that grows almost overnight, assembled with a speed and scale previously unimaginable. For 5,000 years, we built with sinew and stone, muscle and sweat. Now, cold precision guides construction, transforming it from a craft of hands into a function of code. Machines pour concrete like a painter applying vast strokes to a canvas, their movements dictated by digital blueprints with sub-millimeter accuracy. And entire streets awaken with light in a sudden, coordinated bloom, the radical idea for the cities of 2050. We felled forests, carved mountains, laid brick upon brick. The ancient, imperfect rhythm of human labor now work shifts from the physical to the digital. The architect's building information model, or BIM file, becomes the direct instruction set, the G-code for the machines on site. Machines, tireless and exact, take over the building, the lifting, and even the planting. Cities emerge with an aesthetic of speed and flawlessness, clean, sharp, soaring. The shouts and clangors of the construction site fade, replaced by the hum of servos and the whir of electric motors. The human element, beautiful in its imperfection, grows absent, raising questions about our connection to the very idea of home. The speed revolution, printing homes in a day, once confined to small prototypes on a desktop, 3D printing has dramatically scaled up. It's no longer just shaping plastic trinkets, it's shaping our reality. Visionary companies now print entire homes using massive gantry systems or agile robotic arms that move with programmed certainty. In Austin, Texas, a company called Icon has built entire communities of resilient concrete homes, some printed in less than 24 hours. They're not just prototypes, they're permitted, occupied dwellings. The process is deceptively simple. A gantry extrudes a specialized cementitious mix, layer by precise layer, like a baker icing a cake, until walls rise from the foundation. These walls aren't solid, they're hollow, allowing for insulation to be added and for traditional rebar reinforcement to be placed, satisfying structural codes. The digital model accounts for everything, with openings for plumbing, electrical and mechanical systems pre-designed into the print. MEP installs snap into place with minimal rework. In what feels like a blink, a durable, livable house is ready, often within a single day. The speed is staggering. This isn't distant science fiction, it exists today, and it's poised to disrupt centuries of construction norms. Historically, building a home took months, sometimes years. It was a slow, labor-intensive process, vulnerable to weather delays, human error, and spiraling costs. Robotic systems cut that time and waste with surgical precision. They use exactly the amount of material required, reducing the construction industry's massive environmental footprint. The result is fewer mistakes, stronger and more resilient structures, and dramatically lower costs. A streamlined, predictable supply chain means schedules and budgets are no longer vague estimates, but reliable forecasts. The implications are profound. Housing could become far more accessible, finally lowering the barrier to entry for millions and offering a tangible answer to the global housing crisis. This revolution isn't just faster, it's smarter, cheaper, and more sustainable. Opinion. This is the only viable solution to the scale of the global housing crisis. But the path forward is double-edged. Robots could make housing abundant and affordable, or corporations could leverage this technology to own it all, creating a permanent renter class. The job site itself is transforming. Uniform rows give way to organic forms previously too expensive to build. Scaffolding fades, replaced by the elegant dance of a robotic arm. Small teams of technicians supervise the software. Construction is shifting from a trade of sweat and muscle to a discipline of software and code. The new hard hat is a tablet, but speed is just the beginning. This level of automation unlocks ambitions on a scale our cities have never seen before, pushing us toward megastructures once confined to fantasy. In the vast deserts of Saudi Arabia, a vision of unprecedented scale is taking shape. It's a key part of NEOM, a multi-trillion-dollar gamble on a post-oil future. The centerpiece is a project known as The Line. This isn't just a city, it's a linear metropolis. A single continuous structure stretching 170 kilometers, nearly 100 miles, across the landscape. Two towering mirrored walls, 500 meters high, will run parallel, designed to house up to 9 million people in a footprint of just 34 square kilometers. The concept is a vertically layered city conceived entirely without cars. High-speed transit promises to connect its two ends in just 20 minutes, while all daily needs, homes, offices, parks, and schools, are stacked and accessible within a 5-minute walk. It's designed to be powered entirely by renewable energy and orchestrated by a vast network of sensors and AI, creating a responsive, hyper-efficient environment. By building vertically, the line promises to preserve 95% of the surrounding land, a stark contrast to the sprawling, resource-hungry cities of the 20th century. But to realize a city of this ambition, a new kind of workforce is required. An army of machines, operating 24/7. Autonomous crawlers will place prefabricated modules with millimeter precision, while drone fleets lift structural components to staggering heights. On the ground, robotic arms will cut, weld, and finish steel in a synchronized ballet of tireless production. Sophisticated algorithms will orchestrate this flawless assembly, coordinating millions of tasks across a 100-mile construction site. Structural integrity is ensured not just by design, but by continuous sensing and simulation, creating digital twins at an unprecedented urban scale. On paper, it looks like utopia, but the reality of living inside a machine could feel more like a prison. A long, towering wall, even one that is mirrored and beautiful, can still feel like a cage, separating its inhabitants from the natural world outside. In this perfectly optimized world, efficiency threatens to trim away spontaneity. Every movement can be planned, tracked, and optimized for the collective good. The 5-minute city is undeniably convenient, but it may erase the simple joy of serendipitous discovery that defines the world's most beloved urban spaces. Humans have an innate need for sun, wind, and an open sky. An over-engineered living environment, no matter how comfortable, risks dulling the soul. Robots can build us comfort, efficiency, and sustainability. Yet when we cede too much control, we risk trading precious freedom for perfect order. Opinion: living in a perfectly controlled environment, sealed off from the chaos and beauty of nature, is a dangerous experiment on the human psyche. And if the city itself is a machine, its fields will be too. Our traditional food systems are under unprecedented strain. Farmland is shrinking, topsoil is eroding, and our weather is growing more violent and unpredictable with each passing season. The very foundation of how we feed ourselves is cracking. To survive, we need a radical shift. Resilient, sustainable crops grown inside our population centers, insulated from the chaos outside. The solution is to grow up, not out. Vertical farms stack abundance inside city walls. Companies like Aero Farms, Bowery, and Plenty are pioneering this shift to soilless, hyper-controlled cultivation, turning warehouses into year-round farmlands. Inside, there is no soil. Instead, hydroponics and aeroponics feed roots directly with precise, recirculating nutrient solutions, a closed-loop system that eliminates agricultural runoff. Above, high-efficiency LEDs deliver exact light recipes, specific wavelengths of light that accelerate growth, maximize nutrition, and ensure perfect consistency. The results are staggering. By stacking crops vertically, these farms can grow orders of magnitude more food per square foot, up to 390 times the yield of a traditional outdoor farm. They achieve this while using up to 95% less water, a critical advantage in an increasingly thirsty world. Food grown in the city slashes transport emissions and arrives on plates within hours of harvest, at its absolute peak of freshness and nutritional value. A network of sensors and AI-driven automation waters, feeds, and harvests with robotic precision, making output predictable, reliable, and completely climate-proof. For city dwellers, this means fresher, more nutrient-dense food, and a far more resilient local supply chain, immune to droughts, floods, and freezes. But this manufactured perfection comes at a cost. Vertical farming is incredibly energy-intensive. The powerful lights, climate control, pumps, and robots create a massive electrical load. If these facilities are powered by fossil fuels, we are simply trading land and water savings for a catastrophic increase in carbon emissions. To be truly sustainable, these indoor farms must be paired with massive, dedicated clean energy infrastructure and on-site storage. There's also the question of taste. The sterile environment can challenge flavor expectations. The complex microbiology and environmental stresses of soil are what shape the nuanced flavors we know. So we face a choice. Do we accept a manufactured, predictable nature for the sake of stability? Or do we risk the volatility of the old ways in a rapidly warming world? Opinion: we're running out of arable land. If our farms don't move into skyscrapers, we will eventually starve. It's no longer a choice, but an imperative. Housing, megastructures and food. Together they form the pillars of a new machine city. But the ultimate question remains: who will it truly serve? The city of 2050 is a machine, efficient, clean, and automated. It runs not on gears and steam, but on data and code. Automation can free us from danger, repetition, and strain, opening space for creativity, science, care, and learning. But the same efficiency can harden into uniformity, predictability, and control. The core questions aren't technical. They're about ownership, governance, and power. Who owns the robots? Who controls the data? Who writes the algorithms? If technology is open, data protected, and governance democratic, the city can be a shared paradise. If owned by a few, or an authoritarian state, it becomes a tool of profit and control. We are building a potential paradise of steel, glass, and light. Think of the city of 2050 as a mirror. It will not have its own values. It will reflect ours. If we prioritize equity, compassion, and dignity, doors open. If we prioritize power, profit, and control, walls rise. We stand at a hinge in history. Robots and algorithms are merely tools. Will we truly live in this future, participating and shaping it, or merely maintain it for others? We are building this paradise, but will we be allowed to live in it, or just maintain it?